Hi guys, this is Miss Wesley here, and we are ready to start Unit 4, which is all about congruence. So, the first thing we're going to talk about today for Unit 4 Skill 1 is identifying corresponding parts. So take a minute to get our essential question down for today. How do you identify corresponding sides and angles of congruent figures? That's what we're going to focus on. We've done a little bit of this already with the last unit, but we're really going to focus much deeper on this topic now because it's going to come into play the rest of this unit, so you really want to make sure you know how to identify corresponding parts. Alright, so for our first line here, a figure is congruent to another figure if there is a rigid motion that maps the pre-image to the image. And if we think back, this would be true because as long as it's a rigid motion, distance and angle measure will be preserved, therefore forcing the two figures to be congruent to one another. For the second sentence here, a rigid motion always produces a one-to-one mapping between the pre-image and the image points. So what we say is that one figure can be mapped onto the other figure, and that's all because rigid motions produce congruent images. And therefore, what we can say, I'm going to give my handwriting a try here, that corresponding sides and angles of congruent figures are congruent. So therefore, if you have a side in your original shape, its corresponding side in the new shape would be congruent to each other as long as a rigid motion mapped one shape onto the other. So let's take a look at this example we have here in example 1. In the figure below, triangle ABC has been mapped onto XYZ by this transformation. That capital R stands for rotation. P is telling me it's being rotated around P, and the 240 degrees tells us how many degrees it was rotated. So the first thing the question wants us to do is list the 6 corresponding parts, meaning angles and sides. So if you think back to the previous unit, one of the things Ms. Griffin mentioned in her videos a lot of times was stacking the letters of the triangles above each other. So off to the side I'm going to have A, B, C, and then below it I'm going to write X, Y, Z. And by doing so, I'm able to figure out quickly 3 of the corresponding parts. So for instance, angle A would match with angle X. So if I was to put a little mark over that, angle A and angle X. So I'm going to mark that down as one of my corresponding parts. Angle A is congruent to angle X. If I look at the next pairing, angle B would correspond with angle Y. And my last pair of congruent angles would be C and Z. Angle C is congruent to angle Z. So that's 3 of my 6 corresponding parts. Right there I just took care of the angles. But we still have to figure out the corresponding sides. So again, you can use the same idea and say, okay, my first 2 letters here are A and B. So A and B are going to correspond with X and Y. And if I double check my picture, AB, XY, those 2 sides do in fact correspond. So I'd say AB is congruent to XY. If we take a look at the next 2 letters, B and C, my second and third letter, would match with Y and Z. Sorry, B, C, and then Y, Z. And then the last 2, and I know it's getting a little bit hard to read here, my first letter A, my last letter C, first letter X, last letter Z. So side AC would correspond with side XZ. And again, if I go back and check my picture, AC down here would match with XZ over here. And then the middle one that I forgot to mark up quickly was BC is congruent to YZ. So the next question says, is it a rigid motion? Explain. So if we think about what was happening, we know it was a rotation around P of 240, and we know rotations do not change the distance or the angle measure, which would make it a rigid motion. So we'd say that. Yes, because rotations preserve distance or side length. So again, it's really important here that you have two pieces of information in your sentence. You have to identify what transformation is occurring, which is a rotation, and you have to tell what's special about that rotation, which makes it a rigid motion, and it's because it preserves distance or side lengths. So the second question says, are the corresponding parts then congruent? So this time, again, we're going to say yes, and it's because rigid motions always produce congruent corresponding parts. And I got that from right up above here. Rigid motions produce congruent images, and we said because of that, they produce corresponding sides and angles that are also congruent. So it's really important here that you say yes, rigid motions always produce congruent corresponding parts, because if you just say they produce corresponding parts, well, that's not getting at the question. The question says, are they congruent? And in fact, they are. And again, it all goes back to the idea because distance and side lengths are preserved. So the last part of the question here says, my battery's low, so hopefully this video doesn't die. It says, if the measure of angle A is 32 and the measure of angle Y is 64, determine the measure of angle C. So I'm going to go back up here to my picture and I'm going to label them. It says angle A was 32 degrees, so that's right here, and Y was 64. My goal is to find C, so I'll put an X by C since there was no X already in my picture. And if I look at this here, it says angle B is congruent to angle Y. So if Y is 64, that's going to mean angle B is also 64. And now I know 2 out of the 3 angles that I'm looking for. So we can go back and use our property that says all the angles in a triangle add up to 180. So we can make a little equation that says x plus 32 plus 64 equals 180. If I add up 32 and the 64, I'm going to get 96. Take 96 away from 180. And we're going to figure out that the measure of angle C will equal 84 degrees. You could have also solved this problem by taking the 32 and moving it over to angle X, and then saying, okay, I'm going to find Z, and we know that Z is the same as C, and you would have gotten 84 degrees either way. So main idea so far is that corresponding parts of rigid motions are congruent, both the sides and the angles. So let's take a look at what happens on page 2. All right, so we have quadrilateral W, X, Y, and Z was rotated to map onto the quadrilateral LO and M. Complete the congruent statements below. So the first thing I'm going to do is I'm going to take my letters from W, X, Y, and Z. I'm going to take my letters from L, O, N, and M, and I'm going to stack them one above the other so I can figure out which are my corresponding letters. So I have W, X, Y, and Z, and then underneath I'm going to write L, O, N, and M. So what this allows me to do is if I'm looking for LO, I can quickly now identify, well, that LO would go with WX. And if I check my picture, LO, WX, those do in fact look congruent. The next one, angle N. Well, angle N is right here, and above angle N, I see the letter Y. So N is congruent to Y. If I mark that, N and Y would go together. Take a second and try the next two. Pause the video, pause me, and see if you can get it right. So I'm going to pause right now, you pause, and then when we come back, they'll all be filled in. Okie dokie, so hopefully for XY you figured out ON. You can see my green scribbles under XY would match up with ON, our two middle letters, and then angle Z on the end here would correspond with angle M. So because it was rotated, and we know rotations are rigid motions, the corresponding parts are therefore congruent to each other. Last example, example 3, triangle cat is reflected over line N. So again, right there I'm noticing that it's reflected, and I'm saying to myself reflections are rigid motions, so the corresponding parts are going to therefore be congruent, such that it maps the triangle onto triangle DGO, where, and we have a bunch of these now statements, so AT is 6y plus 15, CT is 8x plus 4, OG is 39, DO is 10x minus 8, DG is 32, and lastly, angle D is 53. No, that wasn't lastly. A plus C is 112. So before I go and even attempt to find X, I'm going to pause the video and I want you to do the same and label the picture with each of the pieces of information that it gave you. So for instance, if we were to do the first one together, it says AT is 6y plus 15. So by AT, I'm going to simply write 6y plus 15. So I want you to pause the video, label the rest of your pictures, and then come back and press play. Alright, so hopefully your picture is labeled like mine. I know that 8x plus 4 might be a little sloppy there, but check out your markings, make sure you copied everything down right, you have the correct numbers for everything, and we're going to take a look at finding the value of x. So the first thing I'm going to notice is that I only have x's in two locations. I see x on segment CT and I see an x on segment DO. So I first want to make sure that those are corresponding parts. So remember, you can always go back and take the letters that it gave you and stack them one above the other to ensure that you're setting corresponding parts equal, because we don't want to set parts that are not corresponding equal to each other. So CAT, and then I have DGO. So if I was given CT, first letter, last letter, and I was given DO, those are in fact corresponding, and since the triangle was reflected, we know it's a rigid motion, so therefore we can take the two pieces that have CT and DO and set them equal. So I could say CT is going to equal DO, and now I'm going to swap out the segments for the numerical values. So for instance, CT was really 8x plus 4, and DO was 10x minus 8. And now it's variables on both sides, so let's move our 8x over. I always subtract the smaller of the two first, or move, I should say, the smaller of the two. So I'm going to have 4 equals 2x minus 8. I'm going to have to add 8 to both sides, so I'll get 2x equals 12. So if you're working alongside me, we should end up with x equals 6. So now that I know what x is, it says find the length of DO. Well, if I look back up here, DO was 10x minus 8, so I'm going to take out the x and replace it with the 6 that I just got. So 10 times 6 minus 8. Well, 10 times 6 is 60, minus 8, and we're left with 52. So now a quick question for you here. If we know that DO is really 52 in length, that would also make it true that CT would be 52, since those were corresponding congruent sides. Last question, find the measure of angle O. So I'm looking for angle O, which is up here, and by looking at my corresponding parts, angle O is going to be congruent to angle T. So if I knew any other angles in triangle CAT, that would be helpful, but I don't. The only angle I know right now is angle D, which is 53. And if I know D is 53, C is also going to be 53. I don't know why I wrote that backwards. Well, I only have one angle, so there's no way you can find a missing angle in a triangle if you only know one angle. But go back to this what we were given, because there's something we haven't used yet. It says A plus C is 112. So if I know C is 53, and I know A plus C has to give me 112, I'm going to first take a second and take 112 minus 53. When you do that, you'll end up with 59. So I now know angle A is 59, which would also force angle G to be 59. And since I know two of my angles, I can now use our 180 rule. That says angle T, which would be the same as angle O, plus 59 plus 53 has to give me 180. Well, 59 and 53, we already know that that's going to add up to give us 112. So angle T plus 112 equals 180 minus the 112 over. And we're going to be left with angle T equals 68 degrees. The question said angle O though, but again, if I look, angle T would correspond with angle O. So therefore, the measure of angle O is also 68 degrees. So big ideas for Unit 4, Skill 1 are essentially use your letters to help you figure out your corresponding parts, and then remember, as long as a rigid motion occurred, you can set corresponding parts, both sides and angles, equal to each other to help you figure out whatever missing values you're looking for. All right, I'll see you next time. Bye.